And now, throwing it over to Miranda with our space weather on the 7s for our weekend solar forecast. How's it looking up there, Miranda? Thanks, Miranda. It's looking like a stormy one out there. Solar storm, that is. It's actually a part of a chain of solar storms that have been hitting Earth over the past few weeks, which means you can expect a 60% chance of northern lights if you live above 50 degrees latitude. So get out and look up. On the other hand, we're recommending astronauts stay inside this weekend. Better to stay safe inside the space station than get caught in that storm up in space. Back to you, Miranda. Space seems like an endless void, but there's a lot going on up there. So grab a cosmic umbrella. I'm about to tell you about space weather. Hi, I'm Miranda Cosgrove. Welcome to the STEM Loft, where the landlord said it wasn't haunted and was honestly really weird about it. Let's start with solar wind. The sun isn't just a static sphere sending us sunbeams. It's constantly putting out energy across the entire electromagnetic spectrum, from the visible light we know and love, to radio waves, X-rays, and even gamma rays. But the corona of the sun also sends out a stream of charged particles called solar wind. This solar wind is mostly electrons and protons in a high-energy state of matter called plasma, where the electrons have separated from their atoms. On Earth, we're used to solids, liquids, and gases, but plasma makes up 99.9% of the visible universe. So the sun can never do you a solid. You're getting plasma, and that's it. This solar wind is constantly flowing outward from the sun, and it helps protect us from dangerous galactic cosmic rays from beyond our solar system. Engineers at NASA even think solar wind can be harnessed for space travel with solar sails. But solar wind can drive some big changes on planets. On Mars, for example, it's thought that solar wind eroded the atmosphere, turning it from a warm, wet world with a thick blanket of carbon dioxide to the cold and dry planet it is today. Fortunately for us here on Earth, our planet's powerful magnetic field deflects most of the solar wind. But plasma particles of the solar wind do sometimes get caught in Earth's magnetic field lines, and when they interact with gases in our atmosphere, it can cause the striking auroras you see near our poles. But it's not just solar wind that the sun can send our way. Inside the sun, powerful magnetic fields churn and shift, building up energy that can explode in bursts called solar flares. These flares can last minutes or hours, and while most of them don't have any effect on Earth, some can disrupt satellites and GPS navigation, which makes sense. According to NASA, large flares can, quote, release enough energy to power the entire United States for 1 million years. That's a lot of energy. We love charging our phones here. But the most dramatic space weather event might be the coronal mass ejection, where explosions from the sun's churning magnetic fields expel billions of tons of plasma from the sun's corona. Unlike solar flares that are mostly electromagnetic radiation traveling at the speed of light, these coronal mass ejections travel at a much more leisurely pace, with fast ones approaching 7 million miles an hour. Since the sun is 93 million miles away, it can take hours or days to even reach us. And once again, the Earth's magnetic field normally protects us. But things aren't always normal. Coronal mass ejections have their own powerful embedded magnetic fields. And if they're big enough and aligned in the wrong way, it can distort Earth's magnetic field and cause a geomagnetic storm. The biggest geomagnetic storm on record happened in 1859, known as the Carrington Event. This storm was so powerful, the aurora borealis was seen as far south as Cuba and Jamaica. It ranked as a G5, the highest ranking on the scale of space weather events. But it also shut down the most advanced communication technology of the time, telegraphs. Across the world, the storm overloaded telegraph networks, destroying batteries and transformers, even starting fires and physically shocking operators. That's because geomagnetic storms can induce currents in wires, and why a big geomagnetic storm is one of the scariest forms of space weather. In May 2024, we experienced a powerful solar storm that also made the northern lights visible pretty far south down in the United States. Although it also was ranked as a G5, this storm was not even close to the power level of the Carrington Event. Just as all Category 5 hurricanes are not created equal, some G5 solar storms are much bigger and more damaging than others. In today's interconnected and electronic world, a Carrington event-sized storm, or maybe even one bigger, could seriously disrupt civilization. One study estimated that in the US alone, millions of people would be without power for up to 2 years, and it could cause $2.6 trillion in damage. That's a trillion with a T. 2.6 thousand billions. Lack of electricity would disrupt food refrigeration, communication, medicine, transportation, water treatment, and social media. To be safe, please like, subscribe, and hit that notification bell. All this would be what they call extremely bad. And while utility companies have taken steps to try to prevent this from happening, one of the best defenses is knowing when these geomagnetic storms are going to strike. That's where the Space Weather Prediction Center comes in. The people who track Earth weather also track the weather in space. Together with NASA and other agencies, they're working to understand and predict space weather events and even have current space weather conditions and forecasts. I checked this morning and it looked good. But this is pre-taped, so you might be living through a geomagnetic apocalypse. Sorry. So if there's a coronal mass ejection heading our way, we should have a little heads up to prepare the grid. Or, at the very least, watch a few final episodes before we lose electricity. Maybe stream this segment before it all goes down. Could be fun to explain what's going on to the other survivors around the campfire. Hey, it's Miranda Cosgrove, your favorite host of Mission Unstoppable. I'm the only host. And if you want to watch awesome STEM videos and exclusive Mission Unstoppable clips, just make sure you subscribe and hit that notification bell.